Hello students, it's Dr. Yu. We're on to the last part of data visualization, part 4, the 7 numerical relationships. In this final segment, you're going to learn about 7 types of numerical relationships or charts and graphs and how to make those look good. Let's get to it. Here are the 7 types of numerical relationships that we're going to talk about: time series, ranking, part to whole, deviation, distribution designs, correlations, and spatial numerical relationships. First, let's talk about time series relationships. Time series relationships display values across time, where time is always the x-axis and lines are most preferred. So anytime you're showing a time series relationship, you're showing how things change over time. Now, here is a typical line graph. If you just went on to PowerPoint or Excel and you just use the standard template that they give you, this is probably what your line graph will look like in the end. So this is number of Star Wars earned each month by department. And then you can see it makes little different symbols for each of the 3 departments there. And let me go ahead and just, you see this down here. So to understand the dots here, you have to play basketball. So you have to look down here, then you have to look up here, then you have to look down here. And so you're playing basketball all the time. Then here's September, all those things. Star Wars is this weird, like, side thing, like you have to read up to down, which is weird. And then this is angled. Why am I reading at an angle? So not good. Not a good line graph. It's the standard that PowerPoint gives you, but just because PowerPoint gives you a standard doesn't mean that it's good. Okay. Now, if we're going to improve this, the first thing we want to do is we need to consider the context. Are we in the context of explanation or exploration? So in this case, we are looking at the context of explanation. Let's just assume we have a point we really want to make. And in this case, the appropriate display is the time series relationship, because we want to make the point that perhaps marketing is the leading department when it comes, or marketing is falling behind everyone when it comes to Star Wars. So marketing is dropping the ball. So that's what I want people to take away from this graph. That's when I get to this slide, or when I get to this graph, that's what I want people to take away right away, is that marketing is dropping the ball. Right now, it's not clear when I look at this graph, that's the point you're trying to make. I mean, I see a lot of points. I see a point about sales. I see sales had a good May. Is that the point? Or is the point that design apparently hit like a high peak in July? Or is the point that marketing has hit a very low point at 20 in September? There's so many different interpretations of this graph in terms of what the point is. So you have to guide the audience to let them know, this is what I want you to focus on. Okay, so part 1, pick the context. Part 2, or step 2, pick the appropriate display. Now, let's work on this a little bit more. The next thing we got to do is we need to get rid of clutter. If you notice here, we got rid of a couple of things. We got rid of grid lines. That's probably one of the main things. In this line graph, it's not as important that you get this precise number, but you know that 20 is here, 30 is here, and so forth. So the point is we're trying to show change, and we're trying to show specifically that this department is dropping the ball. So this is really the focus of the graph more than anything else. So we don't really need the grid lines as much. Some other things too. You can see that number of Star Wars. So Star Wars was no longer here anymore because we just put it over here. Number of Star Wars earned each month by department. So it's already clear with the months down here already identified that these are going to be the number of Star Wars, because you have a title here to suggest that. But still, we can do more. We can focus the attention a bit more. So notice what we did was we changed the colors of the 3 departments. We made marketing a very bright color, because this is where you want the focus, is on the red. Anytime you do something that's bright, like a red or an orange or a yellow, we're going to look there because bright attracts attention. When you use duller colors, like a dull green and a dull blue, that's going to fade. So bright colors stand out, dull colors fade to the background. So what I want to put the attention on is marketing. I want marketing to stand out because I'm going to be making a point about marketing. The next thing is tell the story. Marketing shows the slowest growth throughout the year. So I have a thesis now. Marketing shows slowest growth throughout the year in terms of Star Awards, because it goes down. And now you can see the thesis matches the line here, so you know the line is referring to marketing. Then, if you want to add more labels, here's what you can do to even make it even more clear. You have the thesis at the top. Marketing earns least star awards throughout the year. We already know this is star awards. You see the angles have gotten fixed here. If you're worried about, so remember in this previous, you have this little legend down here. So we have to play basketball still. So marketing is this. Well, what's the green? Okay, so sales is here, design is here. And you can see how the basketball is getting played down here. Okay, get rid of the legend. Put design here, put sales here, put marketing here. Then I know, and then I'm reading it left to right because now I see marketing earns least star awards throughout the year. And then I can look to the left to marketing and everything's here as well. So it flows left to right, and remember the Z principle, right? We read left to right. So that flows with the eye behavior of the typical audience. It doesn't swim against it like other graphs do. So that's exactly what we want to do here. It's a very easy graph to read. And then if you're doing a written type graph, let's say this was something in writing, you can have little call outs here, and then you can tell a story that way if this is a written graph. So it's not one that you're presenting to an audience in a presentation, it's one that they're going to read about. But even if you were to present it to an audience, this would be totally fine. You can make these progressive, so you could have these appear as you go through the graph. So you could say marketing earns least star awards throughout the year, and then here you go. And then you say you can see here, and then this appears, some growth throughout the summer, but then as you see over time, there's a major slump after July. Okay, cool. And then that appears. So overall, what we're doing is we're just making everything simple. We're getting rid of superfluous items that don't add to the design, and we're trying to make it easy on the eye behavior level for the audience to see the point right away. So if you look at this compared to that, it's not clear what the point is. I don't know what you're trying to do. Don't know what your takeaway. All I know is number of star awards earned by each department. Marketing earns the least star awards throughout the year. Oh, I get the point right away. And I see it right away, and everything is just cleaner, happier, less clutter, and everything is focused. That's what we want in a line graph. That's what we want in a time series relationship. Now, let's go to the next one. Ranking designs. Ranking designs compare discrete quantitative values. They are the simplest graph to read because they're best expressed through bars. Ranking designs essentially are bar graphs. Bar graphs, you look at the bigger bar and the smaller bar, and you go, okay, the bigger bar means more, the smaller bar means less. Okay, that bar is bigger than that bar. I understand what that means. Great. We love bar graphs. Bar graphs are so understandable, so easy to read. The more bar graphs you can use than anything else, the more your audience will love you and understand you, and it's just great. Now, here's a typical bar graph that you might do through PowerPoint or Excel, and this is what this gets turned out if you do Graph Maker on that. Now, we understand that there are some problems here. There are some problems with this graph, and we can start picking it apart right away. First step is consider the context and pick an appropriate display. So the context here is, once again, let's do explanation because exploration is easier. So let's do the harder one, explanation. We want to make a particular point. So perhaps the point we're trying to make is going to be something about how Group A outperformed Group B year over year in purchasing changes. Okay, so when you're saying two things are being compared to each other, what A is better than B, yeah, I think a ranking design makes a lot of sense because a ranking design says X is bigger than Y and Y is bigger than Z. Cool, great, we're on the right track. Now, first thing we're gonna do is eliminate clutter. So now we're gonna get all KonMari and we're gonna get rid of some things. Notice first off, we got rid of all the 0.0 percentages because they don't really matter. There's nothing that really comes down to the decimal point, really. Like there's no like, man, this is 0.6 better than that. No. I mean, most things, it's like you're dealing with differences of tens or ones. So you don't need the 0.0% parts or the tenths and hundreds of percents. The other thing too is, notice here, once again, we're still playing basketball. We have Group A down here, Group B down here. Oops. Okay, went back one. Okay, so Group A down here, Group B down here. Okay, so what we did is, so we don't have to play basketball with our eyes, we just defined in the graph title what Group A is with blue and what Group B is with orange. So when I look at the graph, I just look at the top and then I just look at the bottom. And then I don't have to go back to bottom to understand the top. I just do it all in one single swoop, like that. You see how easier that is to read? than something that you were looking at before? Now, we did one big thing here. Yes, it's nice to look at things vertically, but the human eye is better at looking things horizontally. So to really focus this point, what if you made the graph horizontal? Compare this to that. And if we get rid of, here, let me get rid of all the ink because you're like, it's all messed up. Okay, so let me just erase all the pen. Okay. What if we compared this to that? I think it's easier to notice differences if you look at this graph because everything is horizontal and we read things left to right. We don't read things north to south usually. We read things left to right. So I like horizontal graphs for that reason because it makes the differences clearer as far as the percentages, and I just read it left to right. I don't have to look up and down. And then still we keep our group A and our group B, and everything is still clearly defined. Now, we've focused the point, but we're not done. Now we got to tell the story. The story here is Group A outperformed Group B in purchasing changes year over year. So then it's clear, yes, Group A was better. I mean, you look at blue, blue, blue. Yeah, I mean, Group A whooped Group B's rear end when it came to that. Great, great. So then in the final form, this is how it could look. You have Group A outperform Group B in purchasing changes. And technically, if you wanted, I understand this axis is up here and it kind of, maybe some of you are thinking, could this be moved down south? Yeah, absolutely. And in fact, the more I look at it, I'm kind of like, yeah, maybe the axis should go down. So that was just a design decision. But that way you don't have to worry about this kind of getting in the way of the message and the data. But yeah, totally, you could put the axis on south. That's a fair criticism. But let's just say you're still worried. So some people are worried, I still don't know. People may not know what Group A is. Okay, well then just add a little label in the bar. When you do a horizontal graph, this is possible because the bars are thick enough to allow you to do that. And then we'll know what Group A is as well. So if you're concerned about this titular approach of labeling things, okay, then just put it within the bars. I'm still not playing basketball by having a thing down there, and then I have to look down. For me to understand this, I have to look down here and then go back up to understand everything else. No, I can still go left to right. Everything's cool. So compare this to that. I think I like this more. Easier to read, I get the point quickly, and all that. Next is part-to-whole relationships. So here we're talking about how do parts make up a whole. So it's generally involving colors and sizing, and you're generally going to express these either through pie charts or through bar charts. So your typical pie chart is going to look something like this. You're going to have your customer base, and see, we have to play basketball here because I have to look at what gray is and what orange is and all that. So if you're going to do a pie chart, what I would say is make sure you label the actual pie pieces on top instead of doing this basketball thing, and then maybe put the percentages too, because I don't know which is bigger. Is this bigger or is that bigger? By looking at this pie chart, I'm not sure. I think you have to really look at it. I know this is bigger than these two, but I don't know if this is bigger. So then that's a problem with pie charts. When you have really close data, it's hard to tell sometimes what is bigger than what. So then what you have to do is sometimes you have to add a table. So then you add a table here, customer base, but then in that case, why don't you just run a table? And then literally you could have single, divorced, widowed, married, and then total 100%, and I still get the percentages. I still see that single is 38%, divorced is 24, widowed is 20, married is 18. See here, I wouldn't know, so widowed is 20% and then married is 18. If I didn't have this table to go along with it, I still wouldn't know who's bigger. But in that case, if you don't know from the graph, why do you need the graph? So in that case, I think a table sometimes is actually a better way to show part-to-whole relationships if the items are very close. Now, some people, like the author of your book, Storytelling with Data, and Stephen Few, who she got most of her information from, they're opposed full stop to pie charts. I'm not opposed to them full stop. I just think that you don't want to overuse them, and you got to know when they're actually not appropriate for part-to-whole relationships, like this example here. So then you can try to put numbers on it, and that helps a little bit, and that helps clarify it. But then at what point are you really graphically displaying anything? So that's another thing. Then the other thing you definitely don't want to do, regardless of where you stand on pie charts, don't use 3D charts. because this is even worse. Because now it's like 3D, I have to really put things in perspective to understand is married bigger than widowed and all that. So just don't use 3D pie charts. Don't really use 3D charts at all, because it adds another axis that people have to process. They already have to process generally an X and a Y axis, with the exception of pie charts. When you add this like Z thing, or like this is a perspective here, it's just too much. It's too much for your audience. In a PowerPoint presentation, it just takes away so much. So I know PowerPoint has these excellent 3D looking things that you can do. Don't do it. Don't do it. Here's another way you might do a pie chart though. If you don't like the pie chart concept, why don't you just do a bar chart where everything is percentages? So then you know, okay, so married is somewhere around 15, widowed is bigger than married. That's the point, right? If you're not concerned about specific numbers, you're just trying to show that widowed people slightly edge married people, then this would be just fine. Even if I don't know the exact number, like I know it's like going to be somewhere around 20%, it's somewhere around 18%. Okay, cool. Because my point is just that they're bigger, not like the percent bigger. Like, so in that case, this could be just fine. And if you want, if you're still worried, like, but they need the percentage specific, okay, fine, then do something like this, you know, and that could also be an option as well. So some people are just super opposed to pie charts. I'm like more in the middle. I think pie charts can still be useful, but you got to do them well. And you also have to understand when they are not useful for part to whole relationships. So just keep that in mind. Then you have deviation graphs. So deviation graphs show how values differ from a baseline. So if you're wanting to show how something stands out from an average, or how something deviates from a certain just baseline number, deviation graphs are great. And you're generally going to use those either through lines or bars. I like the bar approach. So here's one that's so this is what PowerPoint would create for you if you just did a deviation graph through them. One thing I would say right away, if you were going to try to improve this, is just add some emphasis. So sales and finance spending exceed the budget. So you can see here, sales is, above 2%, the variance in budget, and finance is, 7%. So you know that two people are behaving badly with the budget. Okay. So if you do a deviation graph, I would just say continue to highlight, tell stories, and all that. We're not going to do another full walkthrough on deviation. But then you have distribution designs. And these show a spread of values across a range, and they'll generally use boxes, graphics, or bars. So probably your most common, or not most common, but just a distribution design that you learn in statistics is the classic box and whisker plot. So box and whisker plots generally are going to show the average and the median and the upper quartile and the lower quartile. And then you can make comparisons on midterm exam scores between two public speaking classes as far as, the outliers and all those things. Now, if you want to use a box and whisker plot in your presentations, I showed this to a tech company of engineers, and they were kind of like, we don't use those. So I don't know, maybe only my stats class used these, but even like the CTO was like, we don't use box and whisker plots. I'm like, oh, okay, all right. So, but they're good. I think they're good for showing distributions, but apparently at least that tech company was like, no. Okay, fine, all right. But then you have histograms. And so histograms show distributions of ranges of numbers. So 7 people got between 72 and 84, and that sort of thing. You learn this in stats as well. But you also have strip plots. I actually kind of like strip plots. Like if you're dealing with small numbers here, number of employees with unused sick days. So you know that 2 have 1 day unused, 3 employees have 2 unused days, 2 employees have 3 unused days, and so forth. So if you're dealing with really small numbers, a strip plot can be a really good way to go. And then you can even make the strips little dots, like maybe you have pictures of the employees and then like you stack them up or something. So there's ways you can get creative with a strip plot, but it shows a distribution of data among an axis. Now let's get to correlations. Correlations are going to relate 2 paired sets of values. And so they're either done through lines or scatter plots. That's generally how you show a correlation between 2 items or 2 sets of values. Now, this is a scatter plot, and one of the big things, once again, this is already more or less improved. So you're going to have your axes. There's a strong correlation between review score and raise percentage. So you have raise percentage here, review score here. And you may be able to get rid of these if if it's clear, like percentage and score, like you're not going to have a review score of 12 and you're not going to have a raise percentage of 95 or 100. Depending on the, within context, people should already know like what the axes are. But if you need to label them, label them. And then, of course, the thesis matches the line here, the line of best fit. And that helps make sense of what the correlation's trying to say. So it's a strong 0.90 correlation between review score and raise. Now, you can also do a spatial numerical relationship, and it's going to relate a value to a spatial location. And these are best displayed by heat maps. Now, you can get really graphic and crazy with heat maps, but just here's like a very basic one. So if you're trying to show where most of your visitors come from, you could do a table or just do a heat map. Show us a map and then say, okay, here are our restaurants. We have one in SoCal and one in Texas somewhere. And, we have 700 to 100,000 visitors that come from here and, 400 from here. And then you have a little heat map that tells you where your highest density of visitors come from. So usually it seems like the southwest here is the highest density, and then a little bit above is medium density, and lower density comes from the north. Okay, great. Now you've highlighted that very quickly. We get it. And now we understand where the hot spots are coming from. The only thing about heat maps is you do have to play basketball a little bit. Like you do have to look up and down to get things. So that is a little bit of trade-off. And there's not an easy way to fix that unless you're making a point like the highest density of visitors come from the south, which here you actually do. So you match this. And so that helps with that. At least you're saying most. So in review, we looked at 7 types of numerical relationships, the time series. So that's going to be something that you're going to show with a line graph, because the x-axis is always going to be time, and then the y-axis is always going to be something else, the thing that you're comparing time to. Your ranking designs are going to be your bar graphs. So one is bigger than the other. I like ranking designs. If you can do everything in a ranking design, do it in a ranking design. Part-to-whole relationships are like your pie charts. Deviation is going to be a bar chart with a baseline. Distribution designs are going to be like your box and whisker, your histogram, and so forth. Keep them simple, have a thesis, highlight, all those things. Correlations, line graphs, perhaps scatter plots, and then your spatial numerical relationships are your heat maps. So now that you've learned what the principles are to data visualization, you can apply all of them to these 7 types of relationships. All of those steps that I taught you on the steps of creating a graph apply to each of these. We didn't go into detail on each of them because we don't want to make this too long, but that's what we're trying to do here. With that said, when we meet in class, we'll do some exercises. We're going to look at some graphs. We're going to critique some graphs, and you're going to bring some graphs to class that we can then help improve to make it more viewer friendly and to get your points across. We'll see you then.